Now in this question it says the standard Gibbs free energy of formation of graphite and diamond at 298 Kelvin are, for graphite it is 0, and for diamond it is 2.9 kilojoules per mole. The standard state means the pressure should be 1 bar and the substance should be pure at a given temperature. The question further says the conversion of graphite to diamond reduces its volume by 2 into 10 raised to power minus 6 meter cube per mole. If graphite carbon is converted entirely to diamond isothermally at 298 Kelvin, the pressure at which graphite is in equilibrium with diamond. So we need to understand that we are talking about a transition of allotrope of carbon, that is from graphite into diamond. So we are talking about this reaction which is graphite converting into diamond. Now if we have to write delta G, the standard Gibbs free energy change for this transformation reaction or transition reaction, it will be the Gibbs free energy for diamond minus Gibbs free energy for graphite at that particular temperature. Putting the value, diamond it is given as 2.9 kilojoules per mole. For graphite it is 0. So for this transition we can say that the change in Gibbs free energy during reaction, the standard Gibbs free energy during reaction is 2.9 kilojoules per mole. Now we know that there would be a change in entropy also because the packing of graphite and diamonds are different. Graphite has a layer structure whereas diamond has a tetrahedral structure. Right, so there would be some change in entropy also as graphite converts to diamond. But we can see over here that the question is silent about that data. Therefore, safely we will have to assume that the change in entropy when graphite converts to diamond, we will say that the change in entropy is nearly equal to 0. Because that data is missing out over here. Okay? Otherwise they would have to provide the data for the entropy change when graphite converts to diamond. So we'll assume that delta S, the entropy change for this particular conversion of graphite to diamond is 0. Therefore T delta S is also 0 for this. Now how we define enthalpy? Enthalpy is U plus PV function. So if we differentiate it, we get change in enthalpy standard is equal to change in internal energy plus change in pressure volume. Further, the question says that the process is isothermal. If the process is isothermal, then delta U will go towards 0. Right? So delta H is equal to delta PV. Further, delta G is delta H minus T delta S. Since data is not given and it is a very less value, therefore we have assumed this to be 0. If data was given, we'll put the value over here. So we know from here that delta G for the transition reaction is nothing but equal to the enthalpy change for the reaction, and it is nothing but equal to 2.9 into 10 raised to power 3 joules per mole. Right? Now enthalpy is defined as what? Delta PV. Now we know that this is a equilibrium. The question says that the pressure at which graphite is in equilibrium. So during the phase change, the pressure is constant. Pressure is constant. So if pressure is constant and H is defined as PV, so it has two terms, P delta V plus V delta P. Because pressure is not changing, so we can neglect the second term, which means that delta H naught for this reaction will invariably be P delta V. Right, where P is the equilibrium pressure inside the container that we have to maintain for this transition to happen. Right. So from here we know delta HR value, which is nothing but equal to delta GR. So if I put the value, I will get the pressure at which this transition is happening. So delta HR naught, which is 2.9 into 10 raised to power 3, and delta V, the question says that the volume reduces by 2 into 10 raised to power minus 6 meter cube. So I think everything is in SI unit. So when we divide, we get a pressure in SI unit, which is Pascal. And we know that 1 Pascal is nearly equal to 10 raised to power 5 bar. So this becomes equal to 14,500 bar. right? That is the equilibrium pressure which is required for transition. Plus it has to compensate for the extra additional standard pressure of 1 bar. Therefore, total pressure at which of the container in which this transition is happening should be 14,500 plus 1. So it will be 14,501 bar. So that should be the answer for this particular question.